Rajesh sir, let's start, sir.
Sure, Vik sir. Yeah, Kalim is there. We have our.
Good morning, one and all present here. Rajapalayam Rajus College, PG Department of Computer Science, in association with ECRIO Incorporation, organize a 5-day online FTP program on adapting to AI-driven industry. I welcome you all for the 4th day of FTP program. Now, I welcome Head of the Department, Ms. D. Saranya, to welcome and introduce our chief guest.
Good morning, everyone, and welcome you all to our Day 4 Faculty Development Program. It's my pleasure to introduce our chief guest, Mr. Kaleem Mohammed, Director of Engineering, ECRIO USA, who has graciously accepted our invitation to join us today. Mr. Kaleem is a highly accomplished individual in the field of private and public 4G, 5G networks, IMS, AIML, and cloud computing. He is skilled in system integration, solution architecture, and mobile network design with strong customer engagement and a focus on delivering innovative communication solutions. We are honored to have Mr. Kaleem with us today to share his insights and experience with our scholars and faculties. On behalf of our college and the department, I'd like to extend a warm welcome to all of you and thank you for taking the time to be with us today. With that, I invite Mr. Kaleem to take over the session. Thank you.
Thank you. Let me present my. That's my famous slides.
Yes, Kaleem, the screen is visible. Yeah. Please go ahead.
Thank you, everyone. So as she mentioned, my name is Kaleem Mohammed. I'm a Director of Engineering at Acrio. I have been with Acrio since 2003. So I worked in various technologies. Currently is mainly focusing on the private networks. So I hope you guys enjoyed the sessions from Krishna Narayanan, Rajesh, and Raghu. In their sessions, you guys heard the buzzword called private networks, private 4G, private 5G. So today's sessions, we can go a little deeper, dive into understanding of what is private 4G networks, what are the private 5G networks, and then we can understand how these private 4G network architecture look like and the 5G networks architecture look like. So how the complete flow of this private 4G, like from the cellular, from the smartphone to how the smartphone is establishing the data connection using this private 4G and 5G. And then after that, we can talk about the differences from what is from the private 4G and 5G networks. What are the enhancement happen in the 5G? And we can also talk about some of the key components of like a spectrum and the SIM cards. All we can discuss in this today's session. Let me do a complete screen share. I just put the window. I'll do the whole window. Okay. I hope you guys are seeing, right? The screen now? Hello? Hello? Okay, so these are the topics I'm going to cover today. Introduction to private 4G and 5G networks. And we can know about the architecture and each in the architecture, the details of each component. And then we can do a simple call flow of the private 4G network. Same thing in the 5G network architecture. and then the component details. And then we can do a simple call flow. Then we'll do the difference between the private 4G and 5G network, and then details of the CBRS, Citizen Broadband Radio Services, space spectrum, we can know about that one. And then there is a detail about the SIM card. And finally, how this private 4G and 5G lab setup looks like. What are the components is required to set up the lab. So introduction to private 4G and 5G network. What they wanted based on their requirement, they can do that. So that's why these are owned and managed by the organizations and industries. So we can customize these private 4G, 5G networks, performance, security. We can enhance the security. We can also increase the coverage based on our enterprise requirements, right? For example, you started coverage for 100 devices. Later, your devices increased like 200, and then you want to increase the area also. You can do all of them in the private 4G, 5G networks. So these private 4G, 5G networks can use edge computing, enabling the real-time processing, reducing the latency, bringing data processing closer to the source. So in the 5G network, you can do the real-time processing, like all these AR, VR, ML things, the data, the content, whatever you are streaming on these networks, you can do a real-time processing right away by keeping the edge processing machines close within the source. So all these networks are owned and managed by the organization. So any sensitive data can remain within the enterprise. So it doesn't go any your sensitive data, because these are all owned by the organization and managed by the organization. So you don't worry about these. Your sensitive data will go outside. Right? If you use in the public networks, so that is managed and owned by the operators. You never know, right? So that's why these private networks are getting popular nowadays. And also these private networks can guarantee more reliable connections and low latency. So the turnaround time is very less, which is critical for the mission critical application like industrial automation, autonomous vehicles, and augmented reality. These are all like mission critical application. So if you have a low latency and 100% connection guarantee, then you can do all of them. So the 5G network provide the ultra low latency. So that's why people are moving into the private 5G networks. Several industries and organizations are adopting these private 4G, 5G networks, such as the manufacturing companies, healthcare companies, logistic and warehousings, energy utilities, transportation, airports, smart cities, defense, public safety, education, mining, construction. All these are adopting this private 4G, 5G networks. So let's look at the high-level architecture, how this private 4G network looks like. So in the leftmost, you have the user equipments. This is a 4G tablet, and there is a 4G smartphone.
There are some basic IoT sensors. These are all the UE components, like the user equipment. And then this UE is interacted to the core network, which is a Evolved Packet Core, they call as EPC, using the radio network. This is called an eNode B. The other name is called the EUTRAM. So whenever you turn on your mobile phone or your tablet, the first thing it finds is the MIB and SID information, which is a master information block in the system information block. These informations, this eNode B, the radio network is broadcasting. So whenever this information your smartphone or the tablet finds, then it will jump onto that this eNode B. And after that, it will start the communication. So these are the radio network and UE. The main components for the 4G network is the Evolved Packet Core. It has a few modules you see. This MME is the mobility management entity and serving gateway, packet data gateway, policy control, which is COUPIS RF, and then the HSS is like a database, which is a home subscriber server. We'll talk more about that one. And then this is a data network. So if your private network want to connect to a backhaul, like your private network wants to have an internet access, then it will connect your private network connected to the external networks. And then it gets the internet access to your user equipments. Let's look a little deeper here. There are some yellow lines here. There are some green lines here. So the yellow lines is the control plane messages. So whenever the smartphone or the UE is interacting with the core, there are two types of messages goes to the core. One is the control plane messages, like a signaling messages. Second one is the user plane messages, which is the actual content. Like, for example, you are streaming a YouTube video, something like that. So that the actual content is called the user plane messages. So before you want to stream, you need to do some kind of a signaling. So the eNode B performs a signaling as well as the user plane. So the signaling will go to the MME, and then MME will do checks with the HSS. Let's go and talk about each component here. The UE, this user equipment, a device that connects to the 4G networks, such as your smartphone, tablets, IoT devices. So your UE will have a SIM card, and that helps the device connected to the network. So in a cellular network, the SIM card is the key component where it has all the necessary information to connect to the network. So it will have a unique identifier, which is called as an IMSI, International Mobile Subscriber Identity. And it also have some authentication key. It also has some important information here. So the UE send and receive a data, which is a user plane messages and control signals to the network to the eNode B. This is the main functionality of the UE. We'll talk about the complete flow in the next slide. So next component is the eNode B, which is a base station. The LTE base station that connects the UE to the core network, which is an EPC, Evolved Packet Core. So managing the radio resources and mobility. It also connects to the MME for control plane functions and the SGW, which is a serving gateway for the user plane data. Next component is the MME, which is a part of one of the key component in the EPC core. This is core module. This MME means Mobility Management Entity. It is a key control plane node in the EPC. It handles the signaling session management for the UEs. It authenticates the UEs with the HSS. So before anything you want to do, you should identify the device because it's the right device is connecting to the core or not. It also challenges the UE to do a authentication mechanism. And it will also establish a secure connections, which is a tunneling IPsec connections. And and then after that, it's establish a bearers. It's a dedicated bearer and the default bearer with the serving gateway and PGW. So basically this MME is the key component in the EPC core. The next one is the HSS, which is a home subscriber server. This is like a database. So whenever we provision a SIM card, so each SIM card has a unique identifiers, which is a IMSI. And then there is a authentication key, and then they will tell you the PLMN value, which is which network you are going to connect. All those details is configured in this home subscriber. So we configure in the SIM card as well as the whole data will be there in the HSS. So basically it stores the subscriber information, user profiles, service permissions, and security credentials, which is like a security keys, authentication mechanism, and all of them. It supports the MME by providing the user authentication, subscription details, and QoS, quality of service, all those. Next component is the serving gateway. This is comes to the user plane side. The main responsibility of this serving gateway is it routes the user packets, which is the actual content packets, between the eNode B2 packet gateway. This packet gateway is connected to your external network. It also buffers data when the UE is in idle mode. For example, you're receiving some data from the external network, which is from the PGW to this gateway, and then your UE is idle. So basically, this serving gateway will buffer that data. Whenever that UE is available, it will send that data back to that UE. And then it also maintains the session continuity during handovers. So handover means your device is moving from one location to the other location, right? So there are set of eNode Bs will be there. When the device moves from one eNode B to the another eNode B, when you are in a session, so it will smoothly transition to another eNode B. So the continuity it will maintain this SDW. The next component is the packet data network gateway. It handles the IP addresses allocations. So whenever the data connection is established, how does your UE can get the IP address? The IP address UE is going to get from the PGW. PGW is the one which is going to assign the IP addresses for the UE. It also enforces the quality of service, and it manages the traffic between the LT network and external networks. This is a component. So if you want to interact with the external network, so you're in a private network, your call or you want to browse an internet, so the PGW is the one which is the gatekeeper, so providing access to the external network. And TCRF is the another one, the component, which is the policy and charging rule functions. This is an optional module in the private networks, but I think some of the enterprises and organizations are also keep this to understand how much of the data is used. So based on that, they can know how much they are going to charge. But in the public network, this is one of the key important modules. So based on this module only, they will know that, okay, user is using this much of data. So for example, you got a data plan of 5 GB. So this is the module will tell you that how much of the data is currently user is using it, how much is left. So based on that, they will start charging the user. And then final one is the data networks. These are the external networks, which is an internet, or your enterprise networks or your external services like IP multimedia systems. Those are all you access through the PGW. These are the components. In the 4G, there are very few components only. But when you go to the 5G network, there are a lot more components. So we can discuss. So let's go and look the flow, how it is going to work. This is the high-level call flow. Whenever a device like your smartphone or your tablet or your IoT sensor turn on, the first thing which will find is the which eNode B it is going to jump onto. So once it performs the eNode B, the first message, which I didn't capture here, it sends a resource request message, which is a RRC message. It sends to the eNode B. And eNode B, based on the eNode B, what is the IMSI in the RRC message, it is going to provision the unique identifier called the IMSI, International Mobile Subscriber Identity. And the eNode B will send a RRC response. Once the RRC response receives from the UE side, and it will do the RRC complete message. This is a normal, so to find out the eNode B, and then it is establishing the connection with the eNode B. The next request, which goes to the MME via eNode B, is called attach request. So if you want to get a data connection on your mobile network or in your tablet, the first message, you have to establish a PDN connection, right? You need to establish a connection. So to establish the connection, it sends a attach request, and it will tell you what type of attach you are going to do. And you are going to tell that I'm going to establish a PDN connection request. And it is also going to tell to the MME that I need a IPv6 and IPv4. And the type of attach is there are two types of attach. It is a EPS attach only and the EPS combined attach. What is the difference between the EPS attach only and what is the difference between the combined attach is? If you say a EPS attach only, which means that you are requesting only data networks. So you don't want any voice or anything. If you say a combined attach request, the device, which means that the device is not only requesting for the data only, it is also requesting the voice, video, whatever the services they have, it is also requesting for that one. So when this message actually from UE, it will go to the eNode B, and the same message, the attach request, the eNode B will forward it to the MME. The MME is the main key component in the core side, which will receive this message. And you see here, these two are yellow, which means that these are all going to maintain the control functions. And SEW is an user plane, but it also does some kind of a control plane. So here you are seeing a NAS. So this is a protocol. What is the protocol they use to send the message from UE to MME is the NAS protocol. So when it receives the message, the first thing MME is going to do is, okay, I receive a message from the UE. First, I want to know this UE is a genuine UE or not. Is it there? So immediately it sends a authentication information request to the HSS by sending a RAT type and IMSI, the International Mobile Subscriber Identity. When it goes and check into the HSS, so based on the SIM card, what we provision, the same information will be there in the HSS. So HSS will look, say that, yeah, this is a genuine one. So it will respond back to the MME, giving some authentication information response, which is called the AUTM. It's called the authentication token. And the expected response, what is the response it is expecting from the UE is also already calculated and give it to the MME. And then the random number will send it to the MME. So once it receives this authentication information response MME is going to request its challenge. Basically, it is going to challenge to the UE that okay, do the authentication request, and then it receives the AUTN authentication token and the random number received from the HSS. Those information it will pass to the UE. UE, what it will do is, as it has a SIM card, inside the SIM card, there is a security key, which is provisioned at the time of the user subscription happen in the HSS. The same key will be there. So the inside the SIM card, there is a application which is running, which will generate a authentication response based on the AUTM and random value and the security key which has it. So it generates. The algorithm they are going to use is the AKA V1. Authentication key agreement is the algorithm they use. So they generate the response, and then the response will send it back to the MME using this auth response. So anything going from the UE to MME is all NAS protocol. Anything going from the MME to HSS is a diameter protocol. These are the two different protocols they use. So it receives the authentication response. So in the authentication response, it has a response code, right? This response is matched with the expected response received from the HSS. If this two is matched, the responses, then the UE is authenticated. So now the MME is going to send a encryption and the tunneling. Basically, is securing the channel. So it sends a security mode command, which is an also HTTPS NAS protocol. Then it established the tunneling, so it do the security mode complete. So after that, the MME is going to check with the UE what kind of services you are looking from. So what is you are expecting the services you are looking. So it send a ESN information request, and then the UE will tell that, okay, I need a data, and then I also need some voice calling and all those, right? Those information, it will send it back to the MME. So once it receives that, so MME wants to know the UE location. So the UE location is available in the HSS. So it sends a diameter protocol request called update location request. And this update location request will go to the HSS, and HSS will give the answer that, oh, this UE is located in this particular location. So now the HSS part is done. So now MME is going to do the tunneling part, which is it is going to create a session request with the SDW. So the protocol it is going to use called the GPRS tunneling protocol. So when it send a create session request to the SDW, which is a serving gateway, the information it is passes in this request is the IMSI, which is information, the International Mobile Subscriber Identity, and MSISDN, which is a phone number. The SIM provides the phone number, that's the one. And the IME, so your equipment identifier, so your smartphone, whatever it is there, the identifier. And then the PLMN. PLMN is the public landline mobile network, which is it will tell you which network you are going to connect to. So this PLMN has the two important values, which is MCC, called the mobile country code, and the MNC, which is called the mobile network code. Based on that one, it will connect to that particular network. And some other parameters also like a APN. So which APN you want to connect. You want to connect to the internet PDN APN, or you want to connect to the IMS PDN, you want to connect to the emergency, right? That is the one it will send it in this create session request to the serving gateway. So basically the responsibility of the serving gateway is the pass-through. So it routes the packets to the PGW. So basically it takes all these parameters and send a create session request to the PGW. So PGW will check the QAS, the quality of service rules, charging policies with the PCRF, and then it allocates the IP response, IP for the UE, like I said. So in this first request, it says like, okay, I need a PDN type for IPv4 or IPv6. So it will have the IPv6 and IPv4. If it is only asking for the IPv4, then it will generate a IPv4. It send a create session response. Then that response will forward it to the MME. So basically what this will do is it will create a tunnel, and then the tunnel is like a pipe. This pipe has two endpoints. The one of the endpoints is the MME side endpoint. So here you have the IP address of the MME. And the other endpoint is when the first request it send the create session request, the MME will have the one endpoint IP address. The other endpoint, it doesn't know what is the PGW IP address, the tunneling address. So it put the placeholder. When the response comes from the PGW, it will add that other side endpoint. So now the create session receives. So now the tunnel is established between the MME to PGW. But I think the tunnel has to happen from the UE to PGW. That's where you send the data. So now what happened is once it receives the session response, it sends a attach accept message. So which means that the attach request is came. So it sends the attach accept. In the accept, you have the IP details, the local IP address. And if it is an IMS application you want to connect, there is a PCSF IP details and all will come in the air. Just the IP details, it's the local IP address you will get it. So once it receives, the UE will send a attach complete response to the MME. So now MME wants to establish a dedicated bearer, right? It will send a initial context setup request. So now it's telling the eNode B to, basically the MME is extending the tunnel to eNode B, and then eNode B will extend this tunnel to the UE. This way, the complete user plane tunnel will be established. After that, the content will be flowing between the UE to the PGW. So it sends the eNode B, and then eNode B, basically it sends the endpoint of the PGW is one side, and it sends the placeholder from the other side of. So eNode B, when it sends the response, it will send the eNode B endpoint. So now the tunnel is established from eNode B to PGW. So now the eNode B will send to the UE, and UE will establish a dedicated bearer. So now one of the tunnel is established from the, so now the endpoint of the UE is known by the MME. So now MME wants to update this, the endpoint instead of the MME endpoint. It wants to update the new endpoint to the PGW, which is it sends a modified bearer request. So instead of MME endpoint, it is going to put the UE endpoint. So that is what this modified bearer request will be. So in the response, so you have the UE endpoint is one end, and then the PGW endpoint is the other end. So now the pipe is established from the UE to external network. So because the PGW has the connection to the external network. Now the device got the data connection. Then now you can browse the internet or the whatever the other services you are looking for. Those are all going to be available to the UE. This is a high-level call flow. I hope you got it. Now let's go to the private 5G. So when you see the private 4G, the components are very few, right? You have an MME, you have a HSS, you have a CW, PGW, PCR. This is a core network. But when you go and see a private 5G, there are tons of components. So in private 4G, there is a limited devices only you can connect. The latency is also medium. So which means that the you cannot do a ultra low latency kind of operations like autonomous car, those automation, industrial automation, those you cannot do it with the 4G network. Only if you want to do a moderate level latencies like voice calls, video calls, those you can do it with that. So that's why the private 5G network came. The architecture looks like you have more devices here. You see, right, there are cranes, there are autonomous cars, you have the sensors, you have AR devices, you have the tablets, you have the cameras. Those are all came. So now the component here, the solid line you see here is the user plane, and all these are the dotted, and then all are the control plane. You see this, these are all modules of the control plane, which is the signaling modules. This is the actual content module. So in 4G network, the radio network is called E node B. In 5G network, the radio is called the G node B. This is the next generation node B. And here you see there are two units. This is the distributed unit and then the central unit. So these are the two, they separated, they made it flexible. So the central unit is mainly serving a control functions, whereas the distributed unit is doing for the low level task, whereas the CU is doing the high level task. So low level task means your user plane data goes through this distributed unit. And then this distributed unit, you can put it into a edge computer so that it is very close to that. Whenever the content comes to that, it's a real-time processing you want to do, like autonomous or you want to do any operations, right? AML kind of thing. So this they separated these two units, whereas in E node B, you don't have this kind of flexibility. And let's go and look at each component. What is an AMF? AMF is the access and mobility management function. In 4G world, this is an MME. So here it's they are calling an access, a mobility management function. And it has some extra functionality, which MME doesn't have it, and here they have it there. So UPF is the PGW functionality, user plane function, and SNF is the session management function. It do the IP assigning the IPs to the user, the session management function will do. And then the UPF is basically it is establishing the connection with the external data network. There are other modules is the AUSF. AUSF is the authentication server function. So in 4G network, MME interacting with the HSS subscriber module. Here it sends a request to the AUSF, and AUSF is going to talk to the UDM. UDM is the Unified Distributed Module, which is basically, this is a HSS here. So here there is one more unified distributed repository. So this is an HSS, and then they have more data, so they put a repository here. So in one extra thing they have is the network slicing there in the 5G network, which is not present in the 4G network. So the main functionality is NSS, which is a network slicing selection function. For every UE, it will decide which network slicing mechanism. So for example, you want to do some high, like a real-time, high ultra latency functionality, you want to do that. So you can request to this network slicing function that will allocate a dedicated slicing for that, whatever the bandwidth you need and whatever the latency you need, and those are all it will provide to that. And then there is an NEF, NRF. These are all the network exposure functions, which mean that if any external application need a resources in the 5G network, so they can come and then do a resource request from this NEF and NRF modules. So PCF is the same as a PCRF in the 4G network. It will do the policy charging functionality in this one. So there are interfaces. In this diagram, I didn't put it not to make it too complicated. So I created a separate table. So let's talk about each component. After that, I'll show you the interfaces. So UE is same. So it connects to the 5G network instead of 4G network. It is going to connect to the 5G network. So the UEs are the smartphones, tablets, IoT devices, AR/VR devices, autonomous cars, all of them comes into this 5G network. So because it has a ultralight latency, bandwidth is high, upload download speeds are high. So and then it will allow you to do the real time communication, so real time processing and all of it's there. So the more devices you can connect millions of devices to the 5G network. And it like a 4G, it also has a SIM card that helps the device connected to the network. So you have the all the required information inside the SIM card, 5G SIM card. And it sends and receives data and control signal to the network to the G node B. Here is the next generation node B. So G node B is the radio access point in 5G network, like an E node B, but it has an extra two components, which is called the two physical entities, CU, centralized unit, and DU is the distributed unit. CU manages the higher level tasks like controlling the radio connection, handling the mobility, like a control plane. Basically, the control plane functions is the centralized unit will do it. So you can put this one in wherever you do it. You can deploy on the cloud or anywhere. So DU is the distributed unit, handles at the lower layer. It's like a physical layer level. So it manages the user plane tasks, like a data transmission and radio resource allocation, user data handling. These are deployed at the edge, like NEC, like multi-edge computing machines. And these are the ones handle the real-time tasks, like anything you need to do a real-time operations, this unit will handle it. The next component is the UPF, which is a user plane function. The functionality is same like an SGW. It routes user traffic between the private 5G network to the external network. That's what it will do. And then EMF is like an MME. So it manages control plane signaling from the UBs, including the user authentication, mobility management, connection setup, like what exactly the NMAs do, the AMF will do in the 5G network. SMF is the session management function. This manages the creation, modification, termination of the sessions, and it allocates the IP addresses and handles the establishment of modification of the PDU packet data unit sessions. So basically it allocates the IP addresses to the UE. PCF is the policy control function. It manages the policies related to quality of service, like a PCRF in the 4G network, traffic handling, user access and network resource usage in the 5G network. Unified data management, which is the HSS here. It stores and manages the user-related data such as the profile, authentication data, subscription information. Those are all really maintained in this UDM. AUSF is the authentication server function. So in 4G, MMA directly talks to the HS. Here, ANF is going to talk to the HSS, the AUSF. The AUSF is responsible for authenticating users and devices in the network. It works closely with the UDM. So basically, the AUSF will go fetch the authentication information from the UDM. And then it also works closely with the AMF, because these are the two components is interact with the AUS. So AMF will talk to the AUSF will talk to the UDM will talk to the UDR and get the information. It will pass to the AUSF will pass it to the AMF. NRF is the network repository function. NRF keeps the registry of all available network functions and allow them to discover each other. So AMF, AUSF, all these networks will be, this is a repository function that will maintain all the available network connections. And if anyone wants to, they can go and whoever is available so they can find it from this NRF. So NSSF, as I mentioned earlier, this is the network slice selection function. The NSSF SF selects the appropriate network slice for a given service or UE based on the requirement like QoS, latency, bandwidth. So if any one of your UE or application is needed a ultra high latency or the bandwidth, so it can go and request to the NSSF, and then that will do a separate a virtual connection to that particular application. UDR is the Unified Data Repository. This is a centralized database that stores structured data such as user profile. It also maintains the session information and policy data. Everything will be there. And these modules like an UDM and all go and fetch from this UDR and get it here, which is not there in the 4G network. NEF is the network exposure function. As I mentioned, the external networks wants to have a secure connection with the 5G network. So this is the one to give the exposure the functions to those, and then they can. And then AF is the application function. AF interacts with the 5G network to influence policy decision based on the application. If your application need some extra ultra latency or anything, so this is the one will tell to these components. So what are the interfaces they have in the 5G network? There are a lot of the interfaces because you see too many components, right? So from UE to AMF, what is the interface they use is called N1 interface. Basically handle the signaling between the UE, AMF for registration, authentication, session management. So this interface between the UE and AMF, it does the purpose of this one is it handles the registration, authentication, session management. The protocol it uses is the NAS protocol. But in a 4G, here also it uses the NAS protocol. The next one is the G node B to AMF. So transport control plane signal between the G node B and AMF for UE mobility connection setup. So it is the next generation application protocol it uses. The interface it uses the N2 interface. G node B to UPF, which is the user plane function, the transfer user plane data between the G node B and UP for the packet forwarding and routing. It uses the GPRS funneling protocol for the user plane. And then the interface it uses the N3. The next one is the session management function. Between session management function and UPF, the interface it uses the N4 interface, manages the session setup, modification, tear down between the SMF and UPF. So it uses the PFCP, which is called the Packet Forwarding Control Protocol. Next one is the N5 interface is used between the PCF and application function. Basically, it requires a specific QAS and policy rules for a certain application from AF to application function to the PCF. The protocol they use the REST API uses the HTTP. From PCF to SMF, from the policy control function to the session management function, the interface it uses the N7 interface. It sends the policy rules, QoS requirement, and charging rules from PCF to SMF. And the protocol is the HTTP REST APIs. Next, the UDM, which is the HSS in the 5G world, in the 4G world, the user unified data management and the access and mobility management function. Basically, it manages subscriber data retrieval between the UDM and AMF for the user profile, subscription, information, and authentication data. The protocol that uses the HTTP. Next is the UDM SMF. So the session management function also required some data from the UDM. So it uses the N10 interface, the transfer session related data, which is a QoS, IP address allocation between the UDM and SMF. The protocol it uses the HTTP and REST APIs. Next is the AMF and SMF. The communication between the AMF and SMF, the interface it uses the N11. The AMF to request session establishment. AMF will request the session establishment in 4G world. The NME is requesting a create session request to the SGW. And then from there, the SGW to the PGW, right? So the same thing here. AIM request session establishment or modification release from the SNF. The protocol it uses the HTTP, REST API. From ANF to AUSF, so ANF wants to know the authentication details from the AUSF. So the interface it uses the M12 interface. It exchanges the authentication data between the ANF and AUSF. The protocol it uses the HTTP REST API. AUSF to UDM. When AMF receives ASF, ASF will go and retrieve the data from the Unified Data Management. So it uses the M13 interface, and it allows retrieve the authentication data from the UDM, and the protocol it uses the HTTP REST. Next is the PCF UDR, which is an N5 interface, N15 interface. It enables the PCF to retrieve or store policy-related information in the UDR, and the protocol it uses the HTTP REST. N22, which is between the AMF and the network slice selection function, allows the AMF to request a network slice selection information from the NSSF. It uses the HTTP REST API. NSSF to SNF, the interface it uses the N27. The slice selection related communication between the NSSF and SNF. It uses the protocol is the HTTP REST. NEF2AF application function, exposure function to the application function. It uses the N31. There are some more there. So these are the important ones which I just captured. There are more is there. It exposes network function to external application via the network exposure function for service request analytics. So it uses the HTTP REST APIs. Let's go and look the high-level call flow. So I didn't give because it's too complicated. So I give the very high level what happened, right? Same thing whenever the UE is switch on, power on, it first it gets some MIB, SIB information, and then it sends the RRC request, and then the RRC response. So it has a connection from the UE to the G node B. After it has a connection to the G node B, then it sends basically an attach request, which is called a registration request, and it includes the IMSI, those details. So this register request, the G node B will forward it to the AMF, here the MME. So when it receives this request, it goes and asks the authentication request to AUSF. In the 4G case, it asks to the HSS to give me the authentication request. So when AUSF receives this, so AUSF doesn't have it, it will forward that request to UDM. UDM is the HSS, right? The UDM get that request, and then it goes and get the information from the UDR, which is the Unified Data Repository, and all the information like UUTN, RAND, X-rays, and all of them it will receive to UDM. UDM will forward to AUSF. AUSF will verify this authentication response, and after this verify it, it will send it back to the AMF. So now the AMF has the RAND, AUTN, and the X-rays. So that response is forwarded to the UU. So basically here it is challenging, AMF is challenging to the UU that, okay, I send 401 unauthorized. So, and then it gets the random and AUTN value. This value, it will give it to the SIM card, and SIM card will generate a response string, and that response string will send it to the authentication response here. And this will go to AMF, and AMF receive that response string, match with the X response receives from the UDM, from the AUSF. So if both matches, then the session is the device is authorized. Now the AMF is going to start the session establishment with the SNF, which is the session management function. So when it sends the session establishment, so the SNF is allocate the IP addresses with the UU, and SNS is send a policy rules, checks the policy rules and QoS parameters from the PCF, and that information comes back to the SNF. And then once it receives it, then it sends the data path to the UPF. This is the user plane function. So user plane function configure the forwarding rules here, and then it it sends the response back to the AMF. So now all the responses will go. Then AMF will find out the slicing function. So, okay, from this UE, I need a slicing. So it send a request to the NSSSR. So this NSSSR identify the appropriate slice for this particular UE, and then it sends the response back. So with this, the data plane, the connection is established between the UE. So I made it a very high level. There are so many calls out there, but it is a very high level wise. So when you know the 4G, how these things are happening, same kind of, but in the mode modules, it's going to be request to the mode modules here. So before going to the differences between the 4G and 5G network, I want to talk about the 5G deployments. So 5G deployment is happen in two ways. One is the standalone mode. The second one is the non-standalone mode. So what is the difference is the standalone mode and the non-standalone mode is, in standalone mode, for example, there is an industry, they don't have any clear the cellular network like a 4G. There is no private 4G network is there. So they want to deploy a 5G network, so which is called a standalone mode. So they don't have any existing private 4G networks, and they are deploying a complete from the scratch 5G network to that particular organization and industry, which is called a standalone mode deployment of the 5G network, which is a cost effective because they need to buy everything. They have to buy the radio network, they have to buy the core, which is like all the core modules and all of them. So everything will be they have been install everything from the scratch. So it's an effective. It is a time taken because everything is they're doing from the scratch. The second one is the non-standalone mode, which is the industries or organization, they are already have the existing private 4G network. So they have already private 4G network. They want to upgrade to the 5G network, right? So what they do is they don't need to buy everything from the scratch. They can just upgrade the 5G components into their existing 4G network. So it's called time to market is faster here. So they will have the 4G network, which means that they have the eNode B, they have the EPC core. On top of that, they will put the GNode B and then the 5G core. So for some area, so it's any devices comes, it will first connect it to the eNode B, and then the device tells that, oh, I am a 5G capable device. Then the eNode B will forward the message to GNode B, and then it will check, the GNode B will check that, okay, this device within my range. If it is there, then it will give the 5G functionality to that device if it is not. So basically what I'm trying to say here is non-standalone mode is if you already have some existing 4G network, you are putting on top of the 4G network is called the non-standalone deployment of the 5G networks. So let's go and see the differences between the 4G and 5G. The difference between the 4G and